Hello, students. Let's continue with our lesson. Today we are going to look at trigonometric ratios. I'm your favorite teacher, Edward. What are these ratios? When we say tri, from the word tri, it has to do with three, triangle, three-sided polygon, tri. So when we say trigonometric ratios, it tells us we are talking about something which is three. And these ratios are sine. It is spelled sin, but it's not sine. The short form is sin, but it's not sin, it's sine. So the ratios are sine, cosine, tangent. Sine, shortened as sin, cosine, shortened as cos, tangent, shortened as tan. These three are what we call the trigonometric ratios. Why ratio? I will show you very soon, because whenever you are finding them, you compare one length with another length. Trigonometric ratios, right? And one fact about these ratios is that we apply these ratios to only right angle triangles. We apply it to right angle triangles. So take note of that for me. The benefit of these ratios is that you can use it to find either the side. This one has an upper hand over the Pythagoras theorem we discussed previously. Because for this one, you can use it depending on what you know. You can use it to find either the side or the interior angle of a right angle triangle. Now, if you have a right angle triangle, just like we did last time, we saw last time, this is an example of a right angle triangle. It has three parts, three sides, as we know. A right angle triangle has three sides. It's a triangle, right? So we have hypotenuse, okay? We have what we call the hypotenuse, we have the opposite, and we have the adjacent. So these are the sides, the name of the sides of a right angle triangle: hypotenuse, opposite, adjacent. Great. Now, in our next slide, I want to show you how to identify these. How do you identify these three sides? We said in our previous lesson, that the lesson on Pythagoras theorem, that you can identify the hypotenuse theorem by looking at the side facing the 90-degree angle. So the side facing the 90-degree angle is the hypotenuse. Then when they give you the reference angle, what do I mean by reference angle? I will show you. For example, look at this triangle, small triangle I'm drawing here. If I have this triangle and I put, let's say, an angle here, theta. So here, the theta becomes my reference angle, right? Okay. If I put theta on top here, it becomes my reference angle. So you identify the opposite. When you know the reference angle, the side which is facing the reference angle becomes my opposite. I hope we are following. So hypotenuse is the side facing the 90-degree angle. Opposite is the side facing the reference angle. Then, of course, if you know two sides, then definitely the third side becomes the adjacent. So the adjacent, I don't normally worry students to look for it. When you know the opposite and you know the hypotenuse, the third one becomes the adjacent. The hypotenuse is the one facing the 90-degree angle. The adjacent, the opposite, is the one facing, the side facing the reference angle. Then the other third side is the adjacent. Right. So let's look at some things like this. Can you identify the opposite, adjacent, and hypotenuse for me? Assuming we have this right angle triangle. I'll come to the topic. But let's see if I have this. Let me put theta here. Okay, theta can be any value, which is an angle. Okay, if I call here, let me call here A, let me call here side B, let me call here C. How do we link adjacent, opposite, and hypotenuse to this? Of course, the side facing the 90 is our B. So B is our what? Hypotenuse. Then the reference angle is theta. What side is facing the theta is A. So A becomes my opposite. Then of course, the last one, which C becomes my what? Adjacent. Friends, it's very important to know this. Very, very important. Let's have another example and see. Let's have this right angle triangle. Let me see if I have this. Now let me put my theta here. I want us to identify the opposite, adjacent, and hypotenuse. Let's call this side X, let's call here Y, let's call here Z. Right? I'm just using letters to represent them. How do we identify the opposite, hypotenuse, and adjacent? The side facing the 90 is the X, so it's the hypotenuse. Right? The side facing the reference angle here, the reference angle, of course, is my theta. The side facing the theta is my Y, so it becomes my opposite. Then obviously the last one becomes my what? Adjacent. So you can pause the video and write these things down. It's very important because I'm going to clean them. Right. So pause the video and write it. Now back to my topic. You see, we are going to learn how to apply these trigonometric ratios to a right angle triangle. What are these ratios? Don't forget, we said that the trigonometric ratios are, they are what? Sine, cosine. I'm using their short form. Okay, let me write them in full. Sine, cosine, tangent. On your calculator, you don't see the full naming. You see the ones, the short forms, the one in the bracket. So I'm going to stick to those ones, right? I'll stick to the short ones. So how do we apply them? Normally we use so for this. We use ka. We have heard it before, maybe, probably. And we use toi. It's a common word they have been saying. So ka toi. So ka toi. So ka toi is not the trigonometric ratio. The trigonometric ratios are sine, cosine, and tangent. But we use this so ka toi as a way to memorize them. Right? That is why we use it. What is the meaning of so? The so is standing for the sine, the chi is standing for the cos, and the tan is standing for, the twi is standing for the tan. So what does it mean? For example, if I have a right angle triangle this way, okay, the so, let me draw a right angle triangle first. Okay. Let me put my theta here. A, B, C. All right. So means that, so means that sine theta, sine the angle, sine the reference angle is equal to so opposite over hypotenuse. So this is the ratio. So opposite over hypotenuse. So here when you check the diagram, what is my opposite? My opposite is the one facing the reference angle, which is B, over hypotenuse is my A. I hope we are following. Ka, what is ka? The ka is the adjacent. Okay. Should I transfer the diagram? This is the diagram. Probably if you are lost, this is the diagram. There is no harm in redrawing, so don't worry. Let me redraw it here. Theta is here. Here is C. Here is A. And this place is B. So we are done with so. Let's come to ka. What is the meaning of ka? K means that cos the reference angle is equal to K adjacent over hypotenuse K. So it's a ratio. For all the three, you take ratio, division. So adjacent, what is the adjacent? Here the adjacent is what? My C. And what is my hypotenuse? A. Okay. That is it. Then the last one, toi. The toi is the tan. Tan, the reference angle is equal to, that is the meaning of toi. Tan theta. The theta is the reference angle given in the question, okay? Toi, opposite over adjacent. O, toi, opposite over adjacent, right? So what is the opposite? According to our diagram, the opposite is the B. And our adjacent is what? The C. So that is how you apply it in a problem. And you can use this one to always find the third side when you know two sides of a right angle triangle. I think we can solve question with this. Let's look at this question. We are asked to use the trigonometric ratio to find the value of theta. How do we do it? The reference angle is the theta and they want us to find the value of theta. So you ask yourself, you know they have given you 2 and 3. What do they stand for? What have you been given? Have you been given adjacent, opposite, or hypotenuse? And according to our question, the one facing the reference angle, you see, this one, the 2 is our opposite because it's the one facing the reference angle. Then this 3 is the one facing the 90-degree angle. So these are hypotenuse. So we have been given opposite and hypotenuse. Opposite, hypotenuse. So what ratio do we use? We use sine. So opposite hypotenuse. So I will say sine theta is equal to opposite over hypotenuse, right? So I'm going to transfer this one on the next page. So I will say that sine theta is equal to opposite over hypotenuse, right? So go to the diagram. What is our opposite? When you check our diagram, the opposite is the 2. And our hypotenuse is the 3. So it's 2 on 3. 2 centimeters on 3 centimeters. And they will cancel out. So you get 2 on 3 sine theta. All right. Then what do you do? So we move on. Should we even convert to decimal? Let me see if we can convert, or we do it straightforward. Any way you want to do it. But if you want to convert it, you have to write more decimal places. 6667. You get a recurring number. So if you want theta, what do? You don't divide both sides by a sign. No. Theta will be the sine inverse 0.6667. And how do you press sine inverse of that? You press shift on your calculator, then you press sine. The sine inverse will come. So take your calculators, press shift, press sine. You get sine inverse, you enter this one in bracket, you close the bracket. And you get 41.81. I want to leave my answer to 2 decimal places. So 41.81. But theta is an angle. It's an angle. So I'll add degrees. I hope you are following. Great. Now let's have another question on this. Another question. So you always look at what you have been given and what they want you to do. We have been told to use trigonometric ratio to find the value of x in this diagram. So you see, for the first one, we use the trig ratio to find the interior angle. So you see, with the help of the trig ratio, we have been able to find the interior angle here. All right. Now they want us to use the trig ratio to find the side. And how do we find it? It's possible. It's possible. The reference angle is 50. Here the reference angle is 50 degrees. And this 7 is what? Is the opposite, because it's the one facing the reference angle. So we have been given opposite, and we have been given what? The x is what they want us to find. The x is what? Hypotenuse. So we still use sine. It's not all the time that you use sine, but it seems that these two questions you are applying sine in all. So this is opposite, and the x is hypotenuse, right? So I will say sine. Let me write it here before I transfer. Sine 50 degrees is equal to opposite over what? Hypotenuse. And what is my opposite? 7 over x. I hope you are following. So let's transfer this one to the next page as my solution. So I will say sine 50 degrees is equal to opposite over hypotenuse. At a point when you master these theorems, these ratios, you don't have to be writing opposite over hypotenuse. You can just put your answers, your values there straight. So sine 50 degrees is equal to 7 over x, right? Then according to our calculator, sine 50 is 0.76604 to 4 decimal places. You can continue like that, but I'm writing for that. So we get this. Now we want to find the value of x. So what do we do? 0.76604 times x over 7 on x times x. So the 7 will cancel out, get 0.76604x is equal to what? 7. So what will be our x? How do we get x? You divide both sides by 0.76604. So 0.766 okay, 0.766 it seems it's not going there. So that is what we get. So this one will cancel out. Then you get, so let me skip that step. Better still, I think I can shift my board. The division is 2. Okay. So I will say 0.76604x over 0.76604, 7 over 0.76604. So my x will be what? 7 over 0.76604. And this gives me, let's check according to our calculator. This gives us 9.1 to 2 decimal places. I'll get 1379. So to 2 decimal places, I'll get 14. Go back. X is not an angle. X is a side, and the side has been named newtons. So I'll call this one newtons. Right. I hope you have enjoyed this lesson as well. So this is on trigonometric ratio. I want you to have these ones. Try your hands on these ones. Find the value of theta in each of them. This is where our 90 is. Our 90 degrees is here. So when I solved it, I had this. The first one I had 48.19 degrees, and the second one I had 39.81 degrees. You can try and also see if you have those answers. Thank you, and see you in our subsequent lessons.